again, this is Angelus from Elite PvP recording tutorial 4, part 1 of the tutorial series Let's Make a Memory-Based Bot. In this tutorial we're going to be hooking the receive function after finding it, of course. So we're going to find the function, hook it, and try and find a way to maybe send a packet straight to the client, like acting like we're the server, and we're going to send a packet to the client. So before we start, a user on Elite PvP suggested that I upload my current project base with the progress that I've made so far. Now I would be happy to do that, but the thing is I'm kind of like a little lazy and I don't want to set up anything that's related to code sharing and whatever. So if there's any volunteers out there that would like to set up a similar thing, something like maybe Tortoise SVN or whatever, any code sharing website or host, please do so and make sure it's public, so like everybody have access to the content of that server or host, and I would be happy to do that. However, let's just get started. And before we get started, if anybody would like to do so, just send me a private message with the details and I'll just do my thing. Anyway, let's get started. We're going to start as usual. We're going to start OLE debug and we're going to run the game. Now in patch 5716 they updated something in the tqanp.dll, so you might have to do the whole disabling protection thing all over again, but I think it's only the tqanp. I'm not sure. We'll figure it out. If something changed, we'll figure it out now. Anyway, I already did the tqanp, but you're gonna probably have to do the anti-robot client.dll. So I'm gonna start the game and I'm going to start searching for the receive function. Now the first thing I'm going to do is go to OLE file, attach, and I'm going to attach conquer.exe. Okay, I'm going to hit Shift F9 to continue running the process. Okay, now it's running, and I'm going to switch to the game and I'm going to log in. Yeah, stupid game. Okay, let's try now. Okay, hopefully it won't terminate the process. Okay, it's still working, meaning nothing changed in the anti-robot client.dll. Anyway, so now that I'm inside the game, I'm going to switch back to OLE and we're going to start our search for the receive function. Now, to start with, or to begin with, I'm going to go for view executable models, or just hit Alt-E on your keyboard, and I'm going to find conquer.exe, and inside conquer.exe I'm going to right click, search for, and I'm going to search for all intermodular calls. Now I'm going to make sure they're sorted based on the destination name, and this time I'm going to search for this keyword, which is recv. Now you'll notice there's a bunch of calls for that function in several different places, so what we're going to do is just basically right click, break on all calls to receive. Now one of these breakpoints will be triggered right away, and if you want to act like you know nothing about the game and you'd like to do the same thing and find the same functions in a different game, all you gotta do basically is same steps, and you'll find it. It'll be the same way. The assembly code might look a little different, but if you understand assembly instructions and what's going on inside each function, you'll find your way. You'll find it. But if you don't know what assembly instructions are, or what they do, or what move IECX equals does, or whatever, any other command, you'll find it like a little hard to do that, and it could be very annoying. So I would recommend that you go online, do some research, learn a couple of instructions, assembly instructions, learn the basic things, and then you can start here. Because a very useful thing in all debug, which is the function tracing and the stepping into and over the functions. So yeah, you can literally see what each function does just by like hitting, let's say, F7 or F8 above that on that function, and it'll execute it and show you what went on, what changed. Anyway, that's a total different subject. Now, this point we're triggered right away. I'm going to try and continue running our process for a couple of times and see what's going to happen. Also keep in mind that you don't have a lot of time before you get disconnected. If you keep it if you keep a breakpoint triggered for a long enough, the server will notice that it's not getting any response from you because the packets are stuck, the client is frozen, nothing is going on, so it'll just kick you. Now, the reason those breakpoints are being triggered very often, they're being triggered non-stop, is because the receive function is almost 99.9% of the times is located inside a loop that will just keep going on and on and on. Now, if we Google the receive function and see what it does and what does it take, let's Google the following, RECV, and I'm going to type MSDN, and this should pop these links. I'm going to open the very first link. Now, here's a detailed explanation of what the receive function does. The first thing you notice that it returns an integer. That integer represents, let's look at the return value here. It says if no error occurs and the function succeeded, the receive function returns the number of bytes received. So it returns the number of bytes it just received, and the buffer pointed to by the buff parameter or whatever, which is this one here. This will represent a pointer in assembly code, so that's what will be returned to. So the first return address, or the main return value of the function, almost always will be stored in EAX. So now, as long as the function returns a value, if it succeeded, if it didn't succeed, let's look and see if otherwise, it says here, otherwise a value of socket error is returned. So it'll either return a socket error or it'll return the number of bytes that it just received. So now that I know that, basically they're going to be a check, some instructions that will check for errors, and if not, it'll process what it just received. So right underneath this call here, I see test EAX, GNZ, short, blah blah blah. So it'll test EAX. If the value of EAX equals 0, or like it was below 0, it'll take this jump. But if the value of EAX was greater than 0, it will not jump, and it'll execute this code. So what I'm gonna do is remove this breakpoint and place my breakpoint right underneath this jump at this move instruction here. Now I'm going to run the process. Okay, we're disconnected. That's no big deal. And I'm going to do the same thing here. Here it's doing something different. I'm going to remove this breakpoint. Now EAX is the return value, so it's moving it into EBP minus 25C. Now after that it compares EBP minus 25C with minus 1. If the value is equals to minus 1, or EAX, let's say EAX equals minus 1, it'll simply execute these and then take this jump here. But if not, it'll just jump all the way to a different part of code. So what I'm going to do is follow this jump by hitting enter, and I'm going to place my breakpoint here because that's the part of code that will be executed if the function succeeded. If not, we don't care about what happens if not. So with the process running, I'm going to go back and log in. Now one of these breakpoints might be triggered upon login, but we're going to have to probably disable it. Yeah, this one did, so let's just go view int breakpoints, and I'm going to disable all of these just to be able to log in. I'm going to run the process and I'm going to log in. Okay, now that I'm inside the game, I'm going to go back and I'm going to enable these breakpoints. Now this one were triggered right away after I enabled it, so I'm going to go back and continue enabling the rest of the breakpoints while that breakpoint is triggered. Now I'm going to hit, or before I do anything, this call right here is pretty much going to do the same thing. So right here it moves the value of EAX into ECX. The value of EAX will represent the bytes that it just received or some kind of error. So it'll move EAX into ECX, store ECX in this local address, and then it'll OR blah 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 test ECX GLE. Okay, so it'll simply test the value of ECX, and if there's an error, it'll jump and it'll get the last error. If there's no errors, it'll just continue executing the code. So what I'm going to do is place a breakpoint right here where it's going to continue executing the code. I don't care about the error. And I'm going to remove this breakpoint and I'm going to continue. Now this breakpoint will not be triggered as much. If we kept it here, it'll trigger like even more than this breakpoint. So that means the function is working and it is receiving something. So the breakpoint is going to be triggered anytime, and if you look at the value of EAX, the value of EAX right now equals 60. But let's place a breakpoint back here and run the program one time, a couple of times I mean. Now actually let's place a breakpoint on move ECX EAX after the function was executed. Now if you look here, I clicked the run button a couple of times. Now the value of EAX is this value right here, the FFFF blah blah blah. That should represent -1. If you look here, it'll say EAX equals, and it'll give you the value of EAX in hex mode, and inside those two brackets it'll convert it for you too, and it'll show it in decimal, which will stand for -1. So if I continue with F8, you'll see that this jump will be taken. So because it's -1, the jump will be taken. Above -1, it'll not jump and will execute this code. I hope now you understand why I did this. Now I'm going to hit run a couple of times. Okay, now it's running. Next thing I'm gonna do is, okay, now the breakpoint is triggered again. I'm going to look at EAX, it equals 60. Now I know that the receive function here takes a pointer to a buffer where it's going to store the bytes that it'll receive, and it returns the length of the bytes. So EAX is the return value of that function, of this function, which is the ws2.receive, and the pointer, we're gonna find it somewhere around here, but we're not gonna bother with that now. What I'm going to do is basically see what is it gonna do with that buffer after it received it. So we now have a buffer of and its length is 60 in hex mode. So 60 stands for, I think, 92, no, 96, I think. Yes, I'm just going to run my calculator real quick, and I'm going to type 60. Yes, 96. So I'm going to continue with the like using the F8 and see what is it going to do. Now it's comparing the type of the socket, I think, I'm not sure, and it's going to be 2, so it's going to jump, move, blah blah blah, memset. Now this function, the memset, it sets the value that you give it. I mean, it'll take the number of bytes that you pass to it, which is in this case FFFF, and the value that you pass to it, and the pointer that you pass to it. Now it takes a pointer where you're going to store that value or set that value, and it'll set every bytes of these, a number of bytes in that pointer to the value, which is 0. So if I follow this in dump, you'll see there is some kind of numbers here, but after I call the memset function, they'll turn to zeros. Nothing in there anymore. Google what the memset function does. What that tells me is that it's preparing this memory segment here, this part of memory, to be ready to store something in it, and I'm betting it's going to be the packet. Now, okay, now we have a pointer to the same buffer that it just set to zeros right here, and we have a pointer to a bunch of nonsense, but it's not really a nonsense to me. I can tell what this is. If you count these bytes, every row or every line contains 16 bytes. So we have 1, 2, 3, 4, 5, 6 lines. So I'm going to use my calculator, and I'm going to type 6 times 16 equals 36. What are you talking about? 6 times 16 equals 96. That's the right number. And if I convert it to hex, it's 60. So what I know now is that this is our buffer that the function just received, and it's encrypted. And this is the length of that buffer. Now, what I'm going to do is basically follow the empty buffer, because it'll do something to that buffer sooner or later. It'll store something in it. And what I'm going to do is keep looking at this area here in the memory view, and I'm going to hit F8 and see what's going to happen. So I'm going to hit F8, and it's not zeros anymore. I can see a packet. Now, the packet length is 58. The packet type is 3F1, so if we switch that to decimal, 3F1, that will be 1009, I mean, sorry. And I don't care about the rest of this. Yeah, and this is the packet stamp that it's coming from the server, and this is the server stamp, TQ server. So, what I understand from this is that this call right here First thing, it decrypted the buffer. Second thing, it copied the buffer into this memory segment here. So why don't we follow this call by selecting it and then hitting enter, and look what it does. Try and understand what it's doing. Now if I were like looking at the or searching for the, let's say, the encryption, the game encryption or something like that, this is very useful because it'll take you somewhere, it'll get you somewhere. Now if you're wondering what just happened here, basically this right here is just checking for the arguments that it's like argument 1, argument 2, argument 3, which is 1, 2, 3, and it's comparing them to zeros. If none of is zeros, it'll, if any equals 0, it'll just bypass this call here and it'll return. If not, it'll not jump and it'll execute this. Now this call right here is the cast5 encrypt function. So if I hit enter to follow this, this is how the cast5 encrypt function looks like. So if you would like to exploit the game encryption, do something to it, make it not encrypt packets at all, you can do that inside this call here. So that doesn't really matter for now. Now that I know, let's go back, and now that I know that this call right here decrypts the packet, and this call right here receives the packet and then it decrypts it at this call, why don't I try and find what's calling this whole function, starting at this address, at this instruction, which is push EBP. This is the top of the function, the head of the function. Why don't I try and find what's calling it and see if I can do something back there. So it tells me it's being called in 2 different places. I mean 2 different addresses. Let's follow the first one. Now first one, okay, let's go back. Now one thing I'd like to mention is that I'm going to remove this breakpoint. I'm going to remove this for now too. Is one thing I'd like to mention is that, like I said, the receive function inside the Windows socket library is very is used in a loop almost all the time in any process, in any application or exe. So now that we know that, a loop can execute itself, just repeat itself over and over, or it can be just a function that's being called from a different function, and that function is the main loop. This is, yeah, if I place a breakpoint here, run the process, continue running the process, this breakpoint will be triggered before any other breakpoint that we set on the receive functions here inside this function, and it will be triggered all the time, non-stop. But as long as this little money sign here, I can see it, I know that because of this is a function that's being called somewhere else. It's not just a loop that's repeating itself. So what I'm going to do, I'm just going to follow one of these calls, the first one I'm going to follow, and what I'm going to do is place a breakpoint right here on this call, or actually I'll just place a breakpoint underneath this call. We're going to go back using the star button, scroll a little up to the top of this function, and we're going to follow the second call. Okay, second call, also test CX. Okay, I'm going to set a breakpoint right underneath that call too. Now, we might have been disconnected, so I'll just run the process a couple of times, and I'm going to go view int3 breakpoints. I'm going to disable our breakpoints so I can log in. I'm going to switch back and I'm going to log in. Okay. Now that I'm inside the game, I'm going to switch back to Ole, and I'm going to re-enable these breakpoints. Never mind if it triggered that breakpoint, just go back, continue enabling the breakpoints. Now, this is the currently triggered breakpoint. I'm going to double click on it. Now, what I'm going to do is run the process a couple of times and see what breakpoint is really being triggered. Okay, we have one that's being triggered all the time. And obviously none of the other breakpoints are being triggered. Okay, I'll just... Okay. Now, at this point, this is the function that we were just inside, right here. This is the function that we just were looking at. Now, if this call, if I look at EAX after this call is returning EAX equals 1. So, right underneath that function, it tests EAX, and it jumps if the value is 0 of one of these bit flags. So let's do what is it going to do now. Now I'm going to look at the flags here, C, P, A, Z, Z, S, T, D, O. I'm going to look at these flags while hitting the F8. So I'm going to hit F8 one time and keep looking at these flags. Hit F8. Now you can see one of these bit flags turned from 1 to 0, and the P also is set to 0. So that tells me that jump will not be taken. If I look here, it says the jump is not going to be taken. For this jump to be taken, one of these bit flags has to be 1. I'm not sure which one exactly. You can Google that. But the purpose of what I'm saying is to tell you that if the value of EAX is greater than 0, the jump will be taken. Will not be taken. If the value of EAX is 0 or minus 0 or less than minus 0, it'll always jump and bypass these. So what I'm going to do, as long as I know that it's doing that, I'm going to place my breakpoint right underneath that jump, because that's the code that I'm really interested in. So I'm going to run the process a couple of times. Oh my god, I'm disconnected again. Okay, it's fine. Now, what I'm going to do is delete all other breakpoints and keep this breakpoint here. Remember the address of this function, which is 6083F2. Go back to int3 breakpoints, and if you look here, this is the breakpoint that we want to keep. So I'm going to delete the one above it and everything underneath it. And I'm going to keep this one because obviously this is the only breakpoint that's being triggered very often, and that's what I need, that's what I want. Now, I'm going to disable that breakpoint too so I can log in. I'm going to log into the game. I'd like you to know that I can do this really quick, really fast, and I could just not explain anything, and I could just take you straight where the address is that we're going to be hooking, and you would be like, what the fuck, how am I supposed to find it on my own? That's the point, is just to prepare you to find these on your own. So I'm going to go back to the int3 breakpoints, and I'm going to enable these breakpoints. Now you see it would trigger right away. So I'm going to hit run a couple of times and see what's really going on. Still, it's being triggered very often. Okay. Now, this function, this call here, calls the receive function inside the WS2 library, the Windows Socket library, and if it received anything, it decrypts the buffer, and then after decrypting the buffer, it does its thing, and then it returns right here. So obviously, it's setting the EAX to 0 or 1. I would like to take a guess. If I go inside this function and scroll all the way down, you'll see that it'll either remove 1 into EAX. Where is it? I missed it. It'll remove either 1 into EAX. That tells us that it's returning something like a true value, or it moves 0 if nothing was received. You can go inside this function and make sure this is what's going on here if you'd like to know. But I know that's what it's doing, so once we hit this breakpoint, that means it did receive something. That will we confirm that by looking at EAX because it's 1 right now. So it tests that, and it will, let me just try and understand things here. Okay, what I'm going to do is basically keep hitting the F8 and looking at these instructions and try to understand what are they really doing here. So it'll compare this socket type and it'll not jump. Now it'll jump and discard all of this junk. Okay, jump, compare, jump, it's not 0. Okay. And jumps right here. Okay, now by looking at this function, what I understand is just simply it'll just copy the packet somewhere else after checking the packet type and the packet length, and after comparing the timestamp, maybe the timestamp, I'm not sure, and the packet stamp, which is the TQ server, and once it's done it'll return. What I'm going to do is just scroll all the way to the top of this function right here, and I'm going to see what's calling this function. Now I can see it's taking 2 arguments, argument 1, argument 2. I don't really know what these are right now until I break at this point, but I'm not gonna. What I'm gonna do is instead is follow the parents of this function. What's calling this function? I'm going to follow this, and it'll take me right here. Okay, now this function right here, what I'm going to do simply is it's doing basically the same check. It'll check for test EAX. If a value it'll jump, it'll not jump. I mean, yeah, if a value it'll jump right here. If not, it'll execute this code and return and do pretty much the same thing all over again. So what I'm going to do is place my breakpoint right underneath this jump. And I'm going to continue running the process. Damn it, I'm disconnected again. Okay, that's fine. I'm just going to go to view INT3 breakpoints, and I'm going to disable these. I'm going to log in real quick. Now this process could be very annoying and it could be very irritating, but it's just it's worth it. You know, I like to do these things. So I'm going to go back and I'm going to enable both breakpoints. Actually, yes, I'll just do that. For this breakpoint, we don't need it anymore because we're at the parent function for this. We can come back here anytime we want. So I'm just going to delete this, go back to the INT3 breakpoints and enable the second one. Now continue running the process, and the breakpoint will trigger right away. So with the second breakpoint, with the first breakpoint triggered, or the only breakpoint that we have triggered, let's see what is it really doing. Now I placed my breakpoint here. This right here, it'll just clean after this function and then it'll just return. Okay, so what if we instead follow this jump here? Now I did this to compare the value of EAX. Now EAX equals 0. Okay, what happens if EAX equals 1? So let's follow this jump, because this jump will be taken if EAX is greater than 0. And I'm going to run the process. Now, this breakpoint will trigger. But if I look at the value of EAX, it's equals 1. So it's like returning true or false. It's like creating a function and making that function return true or false. True if something really went on, false if nothing happened. So if let's look at these stuff right here, because when it reaches this point here, it means that something went on. It means that this function returned something positive, returned true. So what I'm going to do is check what's really going on here. So I'm going to hit F8, pushes this value, and it calls this. Alright. Now, these two functions here, they're like, I like these functions because they tell me a lot sometimes. Now, it's basically like reading a U-short value or an unsigned short value of a packet pointer or a packet buffer. So it moves the argument 1 into EAX. EAX becomes the pointer to that packet, and then it moves EAX. Here it moves EAX plus 2, which will represent into AX, which will represent the packet type. And right here it'll move the same thing, the pointer to EAX. Now it'll move a U-short value or an unsigned short value into AX, which will become the length, because the pointer plus 2, that will point to the type. The pointer without any added bytes will point to the length of the packet. So I like this function. Let's go back, and as long as I know it'll read something off of a pointer, and those functions, from my experience, I know what they're used for. It's just basically to read packets. To read packets types and lengths. So why not assume that this is a packet pointer and this is a packet length, because that's what it needs to pass to this function. So let's go back and check the stack. I'm going to follow the first value, which points to, yeah, that looks like a packet dump. It is. Length is 54. The type is 2721. Let's try and make sure this is a packet type. 2721 to decimal. Yes, that is a packet type. Okay, and it's not encrypted. So by now it's passing the pointer to that buffer right here, and if I compare the second argument that it's passing, it's 54, and if you look here, the length is 54 for this packet too. So if you count 54 bytes, you'll end up with a whole packet's structure buffer. So I would like to say that this right here is a very convenient place to place our hook. Now I could be wrong and I could be right. The only way to confirm this is by hooking the function itself and printing the values or the buffers or the packets that it's receiving into the console window, and then I'll know for sure whether that's the correct function or not. So I'll leave it at this for now, and I need you to always remember that this is just one approach to follow a certain function or to find a certain function. There's multiple approaches, like routes and ways that you can try to find a certain function, and you can learn these ways by just googling things, stuff like hooking functions and stuff like maybe basics of reverse engineering and stuff like that, and by learning the basics of the assembly instructions. You don't have to learn the whole thing because it'll take you years to do that, but learn the basics. And while debugging a process, like assume that you went online and learned a couple of instructions, the important ones, the most common and used ones, and then right now you're debugging Conquer Online. I'm telling you, just by going through these instructions, you will learn a lot and you will understand a lot. So do that and you won't be sorry later on, because it'll help you a lot and make your life easier, and you'll find functions way faster. So I'll leave it at this for this tutorial, and I'm going to have to create part 2, and in part 2 we're going to try and hook this skull right here. I want to place a hardware breakpoint on it and see if it pays off. So until the next tutorial, be safe.